So today we're going to look at how to factor a difference of squares. Now before we get to that, we're going to go through a few definitions. The first one is, what is a perfect square? A perfect square is the result of raising a number to the power of 2. Or to the exponent. So examples of those numbers would be 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared is 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared 81, 10 squared 100, 11 squared 121, and 12 squared 144. These numbers should be in your head. Whenever you see them, you should recognize them as perfect squares. Okay? And it obviously goes on. 13 squared, 14 squared, etc. Now, a variable can also be a perfect squared, but that's only if it's raised to an even power. So if you have x squared, or x to the 4, or x to the 6, okay? X squared is created by taking x times x. X to the 4 is created by doing x squared times x squared. X to the 6 is created by doing x cubed times x cubed. So you're pretty much having the exponents. Okay, now we're going to do a little example on the side to kind of identify these difference of squares. Okay, so on the side right here, I'm going to say, let's expand the following. So if I give you x plus 7 times x minus 7, let's make some observations. Both of the brackets have x's and both of the brackets have 7. The only difference is one bracket's addition, one bracket's subtraction. Now let's expand. So let's use FOIL. X times x and x times negative 7. So x squared minus 7x. Let's do the lower one, 7 times x and 7 times negative 7. So that's positive 7x and then minus 49. Now I have negative 7x plus 7x. So when I collect my like terms, those disappear and I'm just left with x squared minus 49. So here's your expanded form right here, x squared minus 49. What we should notice, x squared is a perfect square because it's an even exponent, and the 49 is a perfect squared because 7 squared is 49. Now how can I go from this expanded form to the factored form we started with? Well, the square root of x squared is x. The square root of 49 is 7. There's the 7, and there's the x in each bracket. One bracket's going to have addition, one bracket's going to have subtraction. Let's see if we could have a similar rule if I do, let's say, 2x plus 3 times 2x minus 3. Let's expand it. So 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. And now I do my lower FOIL. So 3 times 2x is positive 6x. 3 times negative 3 is negative 9. These 6's cancel out again, opposite signs. So my final answer is 4x squared minus 9. And again, they're perfect squares. 4 is a perfect squared, x squared is a perfect squared, and 9 is a perfect squared. Let's see if the trick we used before applies here. So if I square root 4x squared, the square root of 4 is 2, the square root of x squared is just x. Take that exponent and divide it by 2. The square root of 9 is 3. Are these numbers the numbers in my brackets? Yes. 2x plus 3, 2x minus 3. So we kind of just came up with a rule for factoring these difference of squares. Square root both terms and then put them in two brackets. One bracket will have addition and one bracket will have subtraction. Now that's great and everything, but you have to be able to identify what a difference of squares is. First of all, it's only two terms. Okay, it's a difference, so there's subtraction, and both of these terms are perfect squares. It's all in the name. It's a difference, a subtraction of two perfect squares. So let's write that in the before we do some more practice with the factoring. I love this factoring. I think it's the quickest one. So criteria 1 for a perfect square or a difference of squares. Number 1, it's a binomial. So 2 terms. Number 2, it's a difference or subtraction. And number 3, both terms. And that's important, both of them are perfect squares. That's why you need to be able to identify perfect squares right away. So you need to know 1, 4, 9, 16, the numbers we came up with at the top. So let's try to factor a few of these. Okay, I have x squared minus 36. X squared is a perfect squared, 36 is a perfect squared. So I'm going to do a little side note here. The square root of x squared is x. The square root of 36 is 6. So now I set up my brackets. One will have addition, one will have subtraction. And the numbers are just the numbers I got when I square rooted. Let's try the next one. I have x squared, that's a perfect squared. The 4 is a perfect squared, and y to the 8, because it's an even exponent, is also perfect squared. So the square root of x squared we already know is x. Then the square root of 4y to the 8, I break it down. The square root of 4 is 2. And then for y, just take that exponent and divide it in half, and you get y to the 4. Y to the 4 times y to the 4 is y to the 8, so I know I did it correctly. Now I put those 2 terms in my brackets. One is going to have addition, so x plus 2y to the power 4, and one will have subtraction. Let's try that last one. X to the 4, that's definitely a perfect squared, and 16 should look very familiar. So the square root of x to the 4 is going to be x squared, and the square root of 16 is 4. So that's going to be x squared plus 4, x squared minus 4. And now you might think, okay, I'm done, but you're not. Your final step for any factoring question should be, check your brackets. Can I factor more? And this bracket right here, it's another difference of squares. So I'd have to say, okay, the square root of x squared is x. The square root of 4 is 2. So I have to break it down again. That first one, I keep it the way it is. But this next bracket, I have to factor it further into x plus 2 and x minus 2. And that's the final factored form. That's full marks, not that first line. Okay, so to recap, square root each term, put it in brackets, one with addition, one with subtraction, and that's it. You just have to be able to identify it as a difference of squares, and then you can use the shortcut, which is amazing. Okay, let's try a few more examples. Now, not all of these are difference of squares, so they're not all going to be factorable, and if they're not, we're just going to write NP, not possible. The first one, it's a difference, there's 2 terms, and they're both perfect squares. So this is good. The square root of x squared is x, the square root of 64 is 8. You do not have to write this side note if you don't want to. I'm just doing it for organization and to show my work. Okay, so I square rooted both terms. One has addition, one has subtraction. I go to number 2. There's a difference? Yes. There's 2 terms? Yes. Are they both perfect squares? No, because the square root of 10 is not a nice whole number. So this is not possible because of that 10. Okay, go to number 3. 2 terms, a difference, and these are perfect squares. So the square root of 4x squared is 2x. Square root of 25 is 5. So we have 2x plus 5, 2x minus 5. Okay, number 4. That is a difference of squares. So square root both terms, I get x squared. Square root the 1, I get 1. I write it in, 1 with addition, 1 with subtraction. But now you should notice That's another difference of squares. So we have to go again. The square root of x squared is x. The square root of 1 is 1. We have to break it down more. You have to get in the habit of checking your final answer for more factoring. In this case, it's easy because you have two equal signs, but obviously that's not going to happen on a test. Okay, number 5. That's a sum. That's not possible for a difference of squares. So no. And the last one. Both of my variables have even exponents, so that counts. That's a perfect square. So the square root of x to the 12 is going to be x to the 6. Just divide it by 2. Y to the 8, the square root is y to the 4. Okay, so we have x to the 6 plus y to the 4, x to the 6 minus y to the 4. And here's a little trick for you because there isn't a second equal sign, but that's a difference of squares because our exponents are even again. So on the side here, the square root of x to the 6 is x cubed, so that's not even anymore. And then the square root of y to the 4 is y squared. So we have x to the 6 plus y4 from before, and our second bracket got factored to x cubed plus y squared, x cubed minus y squared. And that's it. Okay, so I want you to try the second set on your own. Okay, when you get to number 13, I want you to take a little pause though, okay, and check your previous questions because 13 is a little different. Try it on your own, see if you see the trick. If not, come back to the video. Okay, so pause, do number 7 to 12, and attempt 13 before you come back to check your work. Okay, so check your work. Okay, for the first one, you should have had 2x plus 3, 2x minus 3. For number 8, x plus 7y, x minus 7y, because you're square rooting both of the terms. The next one, 3x plus 1, 3x minus 1. Number 10 was not possible because it was a sum. Yes, they were perfect squares, but that doesn't matter. If it's addition, that's a no. Number 11, again, that's not a difference of squares because 3 isn't a perfect square. It isn't a perfect square. And then number 12, x squared plus 5, x squared minus 5. You might be tempted to try to turn x squared minus 5 into another difference of squares, but 5 is not a perfect square. Okay, number 13. We notice the fact that there is subtraction. But my 2 and the 18, those aren't perfect squares. But what I do notice, I can common factor first. So always check, can I common factor? And in this case, I'm factoring out a 2, but each term also has a y. If the y stayed, there's no way that's a difference of squares because y has an odd exponent. So your first step is going to be common factor out that 2y. And when you do that, you're left with x squared minus 9. That's a difference of squares. That I can factor now. The square root of x squared is x. The square root of 9 is 3. So I have x plus 3 and x minus 3. That's factored now. Okay, pause the video right here, and I want you to try number 14 on your own before you take it up. And number 14 was a two-step, so I factored x to the 4 minus 16 to x squared plus 4, x squared minus 4, but you should have noticed that subtraction bracket was another difference of squares that can be broken down into x plus 2, x minus 2. Now when you do that, make sure you don't forget the x squared plus 4 from that first bracket or you're changing your expression altogether. Okay, so that's it for a difference of squares. Check to see if you have two terms. Is it subtraction? Are they both perfect squares? Maybe there's a common factor you have to take out first in order to make it a perfect square. And once you have that difference of squares, square root each term. Put them into two brackets. One bracket has addition, one bracket has subtraction.